Hello, I Kiran Mudrati, Assistant Professor, Department of Computer Science and Engineering, Ballari Institute of Technology and Management, Ballari. Welcome you to yet another class of system modeling and simulation. In the previous video lecture, we started module 3, random number, and covered mathematical models to generate random numbers. The continued version of the same chapter, Module 3, Random Numbers. Here we begin with frequency tests. Let us understand objective, that is purpose and overview of the topics what I'm going to cover. Here we are going to introduce testing for randomness. There are two tests basically, frequency test and autocorrelation test. Frequency test basically used for testing uniformity. Uniformity is one of the basic characteristic of random numbers, and autocorrelation test is used for test for independence. So again, frequency test is used for checking uniformity. It's having two different types of tests. One is Kolmogorov-Smirnov test and chi-square test. In this video lecture, I am going to cover Kolmogorov and Smirnov test. Here we go. Kolmogorov-Smirnov test. Two Russian mathematicians found the algorithm to check uniformity of random numbers. In the previous video lecture, we discussed uniformly distributed is one of the characteristics of random numbers. The mathematical model which we use to generate random numbers, if those are not uniformly distributed, we are going to reject that one. So to test that, two mathematicians, Andrei Kolmogorov and Nikolai Smirnov, found an algorithm. So in this lecturer, we are going to discuss that algorithm. Kolmogorov-Smirnov test algorithm. Here we go. Kolmogorov-Smirnov test procedure follows the following steps. The step 1 is arrange the given random numbers in ascending order. So the random numbers which are generated with the help of linear congruential method or combined linear congruential method. So those random numbers, we need to test it, whether those are uniformly distributed or not. To do that, we are applying the following 5 steps. The step 1 is the random numbers we are putting them in a ascending order. Later, we are computing two values, one is d plus and one more is d minus. The formula is given I divided by n minus ri, and d minus is equals to maximum of ri minus I minus 1 divided by n, where n is total number of random numbers. Step 3 is compute d. D is nothing but the maximum of what we computed in step 2, d plus or d minus. Among these two, which one is maximum? That we need to consider as d. And compute the theoretical value d alpha for a given level of significance, that is called alpha, from a standard KS test table. It will be given by two mathematicians, Kolmogorov and Smirnov test. The table will be given in the exam when you are solving the problem. Okay, and the final step is if d is less than d alpha, then we are going to accept the hypothesis, else we are going to reject it. So to understand this complete procedure or the steps, we need to solve one problem. At that time, you come to understand how exactly Kolmogorov-Smirnov test works. Consider the problem statement. Using KS test, check for the property of uniformity for the input set of random numbers. There are some random numbers are given: 0.44, 0.81, 0.14, 0.05 and 0.93, and the level of significance, that is alpha value, is given 0.05. So here I am applying the KS test algorithm. So totally there are 5 steps what we seen in the previous slide. So now the same step I am applying. How many random numbers are there? Totally 5. 1, 2, 3, 4 and 5. So that I consider it as I. So you need to write 1 to 5. So Ri is given. For that, Ri is nothing but ith random numbers. So I am arranging them in from smallest to largest. So among all these 5 random numbers, 0.05 is the smallest. I'll put first. So later on 0.14, 0.44, 0.81, 0.93. So I arranged them in a ascending order. That is my first step. So second step is compute d plus and d minus. So while computing d plus and d minus, I required I divided by n. I value divided by n. I is nothing but 1, 2, 3, 4, 5. N is nothing but total number of values. So I divided by n. I is how much? 1. N is how much? Total number of values? 5. So I'll make use of a calculator. So I value is 1 divided by total number of values, that is n. Total number is 5. So 1 divided by 5, so gives me an answer 0.2, 0.20. Similarly, again I'm going to use it for 2 divided by 5. So the answer will be 0.40. That will put it here. Similarly, I'll calculate it for 3, 4 and 5. I got the answer, this one. So I'm applying the formula I divided by n minus Ri. That is nothing but d plus. So 0.20 minus 0.05. That gives me an answer 0.15. Similarly, 0.40 minus 0.14 gives me an answer 0.26. Similarly, you need to calculate it for all. So here I put hyphen because it goes negative value. Negative value will not be considered. 0.80 minus 0.81. The answer will come in negative, will not consider. Similarly, I am going to use the formula Ri minus I minus 1 divided by n. So it gives me these values, that is called d minus, that is step 3. Similarly, the solution will continue for step 3. Step 3 is d is equals to maximum of d plus and d minus. So d plus is how much, which is the maximum value? 0.15, 0.26, 0.16 and 0.07, which is the maximum 0.26. So here 0.21 is a maximum. So out of 0.26, 0.21, which is the maximum, 0.26. That is the value of D. So in step 4 is alpha value is given in the problem statement, that is level of significance 0.05. So from a standard table which is given by Kolmogorov and Smirnov table, it is called. So n value is how much? 5 here, and level of significance is 0.05. So you just drag it here like this, 0.05. So the answer is 0.565. So when the value of significance is 0.05 and the input random numbers is 5, n value 5, At that time, d alpha value will be 0.565, and nothing to worry to remember all these values. This data will be given in exam while solving this problem. And step 5 is quite simple. So we are checking d is less than d alpha or not. D value is how much? 0.26. D alpha value is how much? 0.565. So, and this condition, when you check, it is true. So therefore we are going to accept this particular hypothesis, and we consider the given random numbers are uniformly distributed. So you need to take one example as an assignment. Suppose you have five numbers like this generated and desire to perform the test uniformity using the Kolmogorov and Smirnov test. Similarly, you will have many examples as an exercise. You take it from a video question paper and try to solve it. Okay, and this is called Kolmogorov Smirnov test. Similarly, in the next video lecture, we are going to discuss chi-square test. It is also very important test for checking uniformity of a random numbers. Thank you. Namaskar for watching.